So very good day to everybody. Once again, this is Computer Communication Networks, and in this class we discuss about Bluetooth LE. Okay, not Bluetooth but Bluetooth LE, low energy. Then we discuss about Wi-Fi, 6LOWPAN, and then Zigbee. Okay, so this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this golden opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students, and young researchers. So in this class, we discuss about a short introduction towards Bluetooth LE, which is Bluetooth low energy. Then we compare the Bluetooth with the Bluetooth low energy, about Bluetooth 5.0, and then the industrial revolution, the basics of Wi-Fi, wireless fidelity, then about BSS and IBSS, then we discuss about ESS, extended service set, then we discuss about 6LOWPAN, about the characteristics, advantages and disadvantages. So in the third part of today's class, we discuss about a short introduction to Zigbee, about the general characteristics of Zigbee standard, the architecture, and then finally I would like to remind you once again that you have to submit your independent work as soon as possible. And at regular intervals, I'll be giving you some short videos to discuss the knowledge era topics. So this is a short introduction towards Bluetooth LE or maybe low energy. So first mobile phone with the Bluetooth came around 2000, but technology did not pick up. So until 2004, we had an introduction about EDR, enhanced data rate, and only then Bluetooth was very famous. So Bluetooth, there are several revisions, several enhancements have come up, and one revision is nothing but Bluetooth 4.0 or maybe Bluetooth LE. Okay, so currently actually Bluetooth 5.0 is actually going on. Okay, so in 2011 came Bluetooth LE or maybe Bluetooth low energy or Bluetooth 4.0. Okay, so it is nothing but whenever you speak about Bluetooth, generally it is like a wireless headset, okay, or maybe some device which you are going to connect to the data that you are trying to share. Okay, so maybe from the phone to the headset, or maybe from the phone to the laptop or maybe desktop, you can connect them. Okay, but it is similar. Okay, it is actually a wireless communication that lies between the phone and maybe the device you are connecting with. So, okay, so between the phone and the headset, phone and maybe the desktop or laptop with the headset, you can connect it. Okay, so this is Bluetooth M to M, mobile to mobile and IoT applications. So data exchanges for the short range without any wires. Okay, so in engineering like Bluetooth, it's a FHSS, frequency hop spread spectrum technology that extends the data packets within the 2.4 gigahertz. Okay, so these packets will be having like 79 Bluetooth channels. Everything will be having like 1 megahertz bandwidth, and we will have several applications also. Like if you compare Bluetooth and Bluetooth low energy, of course Bluetooth low energy is going to take more power consumption. Okay, and Bluetooth generally, if you can say, it is used for continuous data transmission, not like there is a delay. Okay, so continuously you can stream the data applications. Also another one thing, like 10 to 15 meter only it will be connected. Okay, so it will be connected for a very close range only. So this is the M to M as well as IoT uses for Bluetooth. So just as you see in the diagram, you have the phone, the laptop, okay, the phone which is connected to the voice over internet client application, and from there it goes to the unlimited data pack and the Wi-Fi router to the internet. So this internet will have access with the phone, laptop and other devices. Okay. So Bluetooth generally for consumer products it is very useful. Like we can transfer data, we can actually talk at the daytime at any time. Okay, and you can exchange videos also. Okay, so just like you are in a WhatsApp call, you can transfer messages, and you can transfer videos also. So there are some M to M as well as Internet of Things uses for Bluetooth. So we will be using wireless headsets in your day-to-day life, and also you can use file transfer between devices, and you can use wireless keyboards also. and you can use wireless printers also. Okay, so hands-free calling you can do it in the car, just like you set it on and you can speak them, and wireless headsets like wireless speakers you can use them. So normally you will understand like what is the difference, what is the actual difference between the Bluetooth and the Bluetooth low energy. Okay, so only thing is that Bluetooth devices can be invented and can be recreated even. So you remember like Apple came out with AirPods. Okay, so you can just have it in the ear. Okay, wirelessly it is being connected, and there are several variations also in this Bluetooth connectivity device. Okay, because the thing is that there will be strain on battery life. Okay, so battery or maybe power consumption is too much with the case of Bluetooth low energy. Okay, so power consumption or maybe energy consumption or maybe battery life is a matter of concern. So applications can run on a small battery for a long amount of time. Okay, but still it can be used for exchanging small amount of data even, but only thing is the energy consumption or battery life. So this is the comparison. Like power consumption for Bluetooth Classic, it is high, approximately 1 watt. But for Bluetooth low energy, like low, it is 0.01 watt to 0.5 watt. Communication range, same only. Bluetooth Classic and Bluetooth low energy, it is 10 meter to 30 meter. Normally like 10 to 15 meter only. Okay. But 30 meter you cannot practically get it. Okay. And then data rate for normal bandwidth rate, you will have 1 Mbps, and for 2 to 3 Mbps for extended data rate. Bluetooth low energy, it is 500 kbps to 1 Mbps only. Okay, so for small data rate only it has. And then modulation technique. Okay, so it has GFSK for the BR, and then 8 DPSK for, or maybe pi by 4 DQPSK for EDM. Okay, but GFSK for the Bluetooth low energy. Number of channels for the Bluetooth Classic, it is 79 channels. Each of them will be having a width of 1 megahertz. But with the case of Bluetooth low energy, it is 40 channels, each of with 2 megahertz. Okay. Spread spectrum, it is using FHSS, frequency half spread spectrum. Same for the Bluetooth low energy. Data link layer protocol, it uses time division multiplexes for both Bluetooth Classic and Bluetooth low energy. Error detection, it is using 8-bit cyclic redundancy check or maybe 16-bit cyclic redundancy check and acknowledgement. But in the case of low energy, it is using 24-bit cyclic redundancy check and acknowledgement. Number of active sleeves, it is 7, okay, for Classic, and unlimited for the Bluetooth low energy. So this is the comparison. So we have some applications also, like Bluetooth low energy remains in the sleep mode unless a connection initiates. But the same we cannot experience with the case of Bluetooth. Like it will be going out of connection. Okay. So the actual connection actually only lasts a few milliseconds. Okay, but Bluetooth you can connect for few seconds or maybe few hours also. Okay, so every time the Bluetooth is on, you can connect it. But Bluetooth low energy, it will be connecting like only for few milliseconds. Okay, otherwise it will go to the sleep mode. So short connections are necessary because data rates are significantly higher, like 1 Mbps. Okay, so there are some devices which uses Bluetooth low energy. Like for example, if you go for blood pressure monitoring, BP monitoring, you can go for Bluetooth low energy. Fitbit devices, industrial monitoring sensors, geography based targeted promotions, public transportation apps, okay, or maybe other applications, you can go for Bluetooth low energy. Now we are using Bluetooth 5.0. Actually, advancement of 4.0, we are using into 5.0. For both consumer and commercial use cases, we are using. Okay, so in 2020, the SIG, Bluetooth Special Interest Group, came out with Bluetooth Low Energy Audio. Okay, so it is BLEA. Okay, so it is going to share audio with multiple other devices. So one smartphone, it is going to connect to several other headphones. So that is the advantage. So Normally, this wireless communication technology is how this Bluetooth low energy acts, and it is going to connect to several headsets. But in the case of BLE, Bluetooth low energy, it is going to connect one to one, but here one to many. Okay. So very soon we will be experiencing Bluetooth 6.0 with many advanced features. Okay. So Bluetooth and Bluetooth low energy are similar even. Okay. So we are going to distribute the data for energy savings. So it can handle a lot of data, but definitely it is consumed or maybe it is going to drain your battery life. Okay. So Bluetooth low energy is used for applications which do not require large amount of data exchange and can run on a battery power for many years at a very low cost. So that is the advantage of the Bluetooth LE or BLE. Next we go into Wi-Fi or maybe wireless fidelity. So for the IEEE 802.11 standard, you are using this one for the WLAN, wireless local area networking. So wireless fidelity or maybe Wi-Fi, it is going to connect the internet through the WLAN and then WAP. WAP is nothing but wireless access point. Okay. So every WLAN will be having an access point which is responsible for transmitting data from the users to users as well as receiving the data from users and to users. Okay. So IEEE has some desired standard specifications for WLAN called as the IEEE 802.11. So it will be having physical layer and then data link layer. Okay. So here access point or maybe a wireless access point is a WLAN base station that is going to connect one or more wireless devices simultaneously to the internet. So this is the architecture. So here you will have a number of stations where you will have access point. Through the access point, we will be having a centralized controller. Okay. So you'll be having two station one, two station two. Okay, through the access point one, and maybe access point two, you'll be having two station three and then two station four. So here the architecture will be having two services. One is BSS and then ESS. BSS is nothing but basic service set. ESS is nothing but extended service set. Okay. So BSS you can consider to be the basic building block of WLAN. So maybe you will be having MS mobile stations and maybe an access point which is nothing but the central base station. So stations can form a network without an access point and can be part of the BSS. Okay. But BSS without access point cannot send data to other BSS and which cannot send data means it is said to be a standalone network. So it is nothing but what you call it to be. What you cannot send data, you can call it to be IBSS, nothing but independent basic service set or maybe standalone network or maybe ad hoc network. Okay, so BSS without access point is said to be ad hoc network. So this is BSS and IBSS. So BSS you will be having access point, okay, to the stations, but IBSS without a access point. So BSS with access point, you can call it to be the infrastructure network. Next you have extended service set. So we'll be having two or maybe more basic sets with the access points. Okay, so you'll have access point and from that you will be having the basic service set. So basic service set will be connecting to the distribution system through the access point, and the distribution system can be IEEE LAN such as the Ethernet. Okay. So extended service set will be having two stations, one mobile station, okay, that is nothing but the stations inside the extended service set, and then stationary which are part of the WLAN, wired LAN. Okay. So here you will be having the distribution system, okay, distribution system here, okay, and then you will be having the access points. So there are two frequencies that it can operate. Normally Wi-Fi routers come up with 2.4 gigahertz or maybe 5 gigahertz. Okay. So they are called to be single band routers, but definitely number of several new routers supports both 2.4 as well as 5 gigahertz. So both if it supports means 2.4 and then 5 means it is said to be dual band routers. Okay. So 2.4 gigahertz, it's a common Wi-Fi band, but it can be used by Bluetooth devices like a wireless phones or maybe like a higher order cameras also. Okay. So since the signal is being used by several devices, the signal becomes overcrowded, and definitely the speed also will be very less. So this is 2.4 and 5 gigahertz. The speed is comparatively low with 2.4 gigahertz and high with the case of 5 gigahertz. But range 2.4 gigahertz it's high, but 5 gigahertz it is actually low. So you can say 2.4 gigahertz transmits data at a slower speed than the 5 gigahertz, but does not have a longer range. Okay. So 5 gigahertz transmit at a faster rate, but it is short range. Okay. Next we go into 6LOWPAN. Okay, so it's actually IPv6 protocol or maybe IP Internet Protocol version 6 standard, and it is extended form of this IPv6 over the LPAN. Okay, low power personal area network. Okay, so from the low pan 6LOWPAN we'll have the internet. Okay, laptop, computer, IP enabled devices, servers it is being connected. Okay, so we'll be having gateway, full function devices as well. Okay, this is the full function device. Okay, and this is the gateway. Okay, and then you'll have RFT, reduced function device. Okay, and here it is being connected to the IP communication. Okay, so through the WPAN or maybe wireless personal area network it is being connected. So here the interconnected devices are centered through the person's workspace and connected through the wireless medium, not the wired medium. So 6LOWPAN it is going to allow communication through this IPv6 or maybe Internet Protocol version 6 standard. So it's a network layer protocol which is going to allow communication over the network. It is faster, more reliable even, and you are going to connect it to the large number of addresses. Okay. So it is actually to reduce or maybe to overcome the conventional methodologies that we use for transmitting information. So normally 6LOWPAN is considered to be the best standard for communication across the network. But still it is not efficient because it is going to allow only small devices with very limited processing capability even to establish communication using this IPv6. It is of course low cost, it is very short range, it consumes very less memory and consumes low bitrate even. Okay. So here we will having the edge router and then sensor nodes also. Maybe even the smallest IoT devices will be part of the network and it will be transmitted for a short range. So here you will have LED street light, which is an application of 6LOWPAN. So these are the characteristics. It can interact with the 802.15.4 standards. Okay, maybe like Wi-Fi, and it will be using AES standard. Okay, advanced encryption standard algorithm with the 128 link layer security. And here we will be having a block cipher. We will be having 128 or maybe 192 or maybe 256 bits also. So here, as I told you, encryption, like it is going to protect, it is going to offer privacy as well as authentication features. So here it is going to encrypt the data in the blocks. Everything will be having 128 bits each. So as I told you, it is going to communicate, it is going to interact with the IEEE 802.15.4 standard. So when you communicate with this standard, you can offer link authentication as well as encryption. So here if you see edge router, we will be having the nodes with IPv6 address, and here through the IP enabled devices it is going to connect to the computer. Okay. So through the internet you will be having, and for storage purpose we will be having the cloud, we will be having a sensor for communicating. So these are the basic requirements. Okay. So normally the device should be having sleep mode in order to have the battery saving procedure, and minimal memory requirement will be having, and routing overhead or maybe the time taken for actual processing should be lower. Okay. And then the features, it can be used in IEEE 802.15.4 standard, generally in the 2.4 gigahertz band. Okay. So outdoor range normally like a 200 meter it will be connecting to the maximum. That is the best advantage. Data rate maximum it is 200 kbps only. The maximum number of nodes that it can connect is 100. Okay. So this is how the 6LOWPAN will have. Okay. So it is being connected to the internet through the laptop, through the computer, through the all the devices, server even it is going to connect. Okay, through the gateway and through the full function devices we will be having the IP communication through the standards. And then the advantages and disadvantages. 6LOWPAN, it's actually a mesh network. Of course, you know what do you mean by mesh. So it is robust, it is reliable, it is scalable, it is measurable even, and definitely it is low cost, secure communication, end-to-end encryption it can have for the IoT devices. So as I told you, it's an extension of IPv6, Internet Protocol version 6, and it can be routed to the cloud platforms. So earlier standards it will be having one to one, but here it will be having one to many or maybe many to one routing even. And leaf nodes can be in the sleep mode for a long time. Okay, unless it is being connected, it can remain in the sleep mode. Okay, and then the disadvantages. Still, if you compare with the Zigbee, it is very less secure and less immunity to the interference problem. Like maybe the Wi-Fi and Bluetooth we have the interference, then it will be having lesser immunity. As I told you, it is a mesh topology. So since it's a mesh topology, maybe without them, it will be supporting only short range only. It will not be supporting like 200 meters. And the applications, it's a WSN, wireless sensor network. For home automation, you can use them. And in smart agriculture based devices, maybe if you are using IoT for smart agriculture techniques, or maybe industrial monitoring, you can use 6LOWPAN for these applications. And security, as I told you earlier, it uses advanced encryption standard algorithm with the link layer security. So that is the security level it is providing. And of course, it is having transport layer security mechanisms also. So you can operate with the other wireless devices even. So you can say it is interoperable, okay, in the network. So next we go to Zigbee standard, okay. So you shouldn't confuse IEEE 802.15.4 with Zigbee. Actually, it is a part, okay. It is not exactly IEEE 802.15.4. So Zigbee, it's a PAN task force or maybe task group with the IETF group 4. Okay, so it's a low rate task group 4, and it's the technology that we use it for the home networking. So it's a technological standard for maybe controlling as well as censoring the network. So Zigbee, it's a personal area network of the group 4. Okay, so it is based on IEEE 802.15.4 created by the Zigbee standard. Okay, so for lowest cost implementation of the low power devices and also for low data rate, maybe for short range communication, you can use the Zigbee. Okay, again I'm telling you IEEE 802.15.4, from that only comes a part which is Zigbee. So there are different types of Zigbee devices. We'll be having Zigbee coordinator device, Zigbee router, and then Zigbee end device. Okay. So Zigbee coordinator device, it is going to communicate with the routers, and you can connect the devices also. So coordinator, just connecting, okay, just like a leader. And then router, it is going to pass the data across the devices. Across the devices, we are going to send the data. Okay. And then end device, that is going to be controlled. Okay, end device is nothing but getting the service. Whatever the order coming up, we will perform accordingly. So it is the end device. So this is the coordinator, this is the router, and this is the end devices. So these are the characteristics. Power consumption is very low. Data rate around like 20 to 250 kbps. Short range communication 75 to 100 meter. Okay, network join time is approximately 30 milliseconds, and then it is going to support small as well as large networks like up to 65,000 devices it can support, but definitely practically it can connect only 240 devices. And then low cost of the products and cheap implementation. It's an open source protocol and extremely low duty cycle even. So we'll be having 3 frequency bands with 27 channels. That is the most that it can connect. Okay, and here we will be having 3 types of topology. One is star topology, mesh topology, and then tree topology. With the case of star topology or maybe Zigbee smart energy, it will be having a coordinator and several end devices. End devices, they communicate only with the coordinator, and then we'll have mesh topology. We'll be having one coordinator, several routers, and several end devices also. And then tree topology will be having a central node, which is nothing but coordinator, several routers, several end devices, and the function of the router is to extend the network coverage, because that is what is needed from the tree topology. So these are the layers. Okay, we'll be having from the bottom physical layer, MAC layer or medium access control layer, network layer, security layer, application interface layer, and then finally application layer. So physical layer, it's a lower layer, okay, and medium access control layer, that is actually defined by this IEEE 802.15.4 specification. Physical layer, generally it is close to the hardware and will be controlling and communicating with the Zigbee radio. Okay, physical layer, it is going to translate the data packet in the over the air bits for transmission, and definitely vice versa also during the reception. Then we'll be having MAC layer. It is acting as the interface between the physical layer and the network layer. So maybe for providing the personal area network ID and also network discovery, you can use the MAC layer. And then network layer, it is going to act as an interface between the medium access control layer and the application layer. So for mesh networking, you can use the network layer. An application layer, it is considered as the highest layer, highest protocol layer. Here you will be having application support sublayer and then Zigbee device object. So we will be containing the manufacturer defined applications even with the case of application layer. And here we will be having channel access. Here you will be using CSMA, collision avoidance, carrier sense multiple access collision avoidance. And here we will be having a contention free method, which is nothing but guaranteed time slot, which means that the coordinator is going to dedicate a specific time slot for each of the devices. So we will be having guaranteed time slot. So for home automation, medical data collection, industrial control systems, meter reading, light control, you can use the Zigbee devices. Okay, maybe if you want to control maybe as a remote, maybe you can, if you have to switch it off for all the street lights, you can use the Zigbee technology. So this is the independent work, communication network evolution and recent trends, definition of layers, services, interfaces and protocols. Please submit them in your Google Classroom. I will be checking them as soon as possible.